Hello everyone. We saw on our last green chemistry video, Green Chemistry Part 1, this is the much awaited sequel, we saw that the LeBlanc process was a process that was providing a valuable product in the alkalis that it was producing, but also it was generating a lot of expensive waste and also making a Mordor-like Lord of the Rings wasteland in the surrounding areas. So we needed a better process, and the guy who's going to come up with that is a guy named Solvay, Ernest Solvay. And his process would solve a couple of problems. Also, last time we saw that nature has provided another type of solution. The process that nature uses for energy is a recycling type process where one set of animals, plants, generates a product which is inherently kind of benign itself, also in the atmosphere, and then oxygen, and then that is used by animals and they generate carbon dioxide, which the plants then use. It's this interconnected recycling system that I want to use as basically the definition of green chemistry. And in a way then, nature becomes our teacher. So on this video we're going to explore that topic, and I'm going to show you the Solvay process. In order to come up with a competing process or an alternative process to LeBlanc's, Solvay had a couple of advantages. He was about 50 years after LeBlanc, so he had the benefit of hindsight. First of all, he could see all of the pitfalls and problems that the LeBlanc process ran into. And his dad was a salt maker, so he knew the chemical industry pretty well. So what Solvay was doing was something that people had tried to do already, and so he also had the benefit of seeing the work that those had done. In order to come up with an alternative process to make the alkali that they're looking for, people had tried using ammonia, carbon dioxide, and salt. All right, so Solvay is able to use these processes, but they all had a particular problem in that they generated ammonium chloride as a product, a byproduct. Ammonium chloride is like, again, throwing away something that's worth a lot of money, and it also smells. So if that had been the answer, then it would have been no answer, right? There would have been no competitive advantage for a different process if that was the product. So what Solvay was able to do was he was able to figure out a way to recycle ammonia in the process so that you didn't generate as much a byproduct, and it changed the products overall. So I'm going to show you the reactions in just a second, but this was the major chemical breakthrough that Solvay made. Solvay, in addition, also made an economic or a business breakthrough in that he saw the problems that LeBlanc had in trying to keep his process a secret. Solvay figured out that he could just license the process to others. Then he didn't have to try to protect the secret. So for a small fee, you could pay him and you could make your own. I highly encourage you guys all to go read this series of chapters in Caveman Chemistry by Kevin Dunn. Let's break to the actual Solvay process and let's examine it in some detail. Soda, or sodium carbonate, is the end goal, and calcium chloride is a byproduct. This is the overall chemical reaction, leaving out intermediate steps. But it is important to note that the only byproduct is not really noxious, toxic, or too harsh in a way. This is an improvement over the LeBlanc process already. 4 steps are actually represented in the above single equation. Here they are. Note that some of the products are later used in other steps as reactants. This makes sense, right? You can just think of it as we're going from one reaction vessel to another. Notice something else, and you will see another improvement to the LeBlanc process. Some of the products from later steps can be recycled and put back in earlier steps. CO2 is recycled and put back in the process. Also, ammonia is recycled and put back in the process. If we can come up with some ammonia to start the process, then we can keep the process going with very little additional ammonia. Practically speaking, there's always going to be some losses. We didn't even list ammonia as one of the reactants, since it is just part of the process that recirculates. You can also see that the only two products that are not used in subsequent steps or recycled back into the process are the soda, or the calcium carbonate, and calcium chloride. So what has the Solvay process done better than the LeBlanc process? The major one for producers was that they did not have an expensive product being thrown into the waste bin. In fact, it reused a lot of the products from the process in later steps. This is a huge advantage. The major benefit for the local population was that the waste products were more benign and you could get rid of them in a better way. In the mid-19th century, about 150,000 tons of this alkali are being produced, most of it with the LeBlanc process. 50 years later, the alkali production is going to go to 1.7 million tons. This is a 1,000% increase. Good thing that we found a better process in the Solvay. Remember that the LeBlanc process produced hydrogen chloride and calcium sulfide. Let's cut to the stoichiometry real fast. We can calculate that for every pound of soda, the LeBlanc process also produces a pound of those waste products. Of the pound of waste, about 3/4 is calcium sulfide and the rest is hydrogen chloride. For the chemistry students out there, you can calculate this by determining the molecular weight of the products and then comparing them. Molecular weights are just the sum of the atomic weights for each atom in the proper amounts using the subscripts. Molecular weights give you grams per mole rather than pounds or something more familiar, but you can still just use the ratios between the products' molecular weights, and that's going to be the same as the ratio of the masses in something you're used to. So 1.7 million pounds of soda would also produce 1.7 million pounds of these waste products. The Solvay process is going to have waste products of its own, but remember, they're more benign. The Solvay process is still used to this day, and it produces massive amounts of sodium carbonate. Just by looking on Wikipedia for the year 2005, so it's probably gone up since then. In 2005, 42 million metric tons of soda are produced, and 3/4 of that is produced from the Solvay process, or about 32 million metric tons. The disposal of the waste product, calcium chloride, is still an issue, even though some uses exist for calcium chloride. You may also have noticed that the LeBlanc process produces carbon dioxide, and the Solvay process also produces carbon dioxide. But in the Solvay process, we're able to take at least some of that carbon dioxide, most of it, and recycle it back into the process. No process is perfect, so we're always going to have some amount of loss from even the recycling. So in this way, we can see that the Solvay process also produces less of something else that people consider a harmful waste. Well, I hope you guys enjoyed my presentation of green chemistry. I've tried to, rather than just tell you what green chemistry is, I've tried to give you an actual historical example. So, sometimes people might tell you this is what they're trying to do with green chemistry. I've given you an actual historical example, and that allows you guys to look at it in context and to consider how the big picture fits together. So I hope you guys have enjoyed that, and I hope you got a lot from it, and we'll see you next time.